Let me introduce myself. I'm Federico Drago from Trust IT Services, and I'm part of the FairCore for EOSC project, part of the communications team. And today I am joined by Morane Gruenpeter from Software Heritage and Themis Zamani from GRNET. So today we're going to learn a bit more about software heritage as an example of an EOSC-Core service. So what we will do is I'll just take you through the agenda. So as you can see, it's very simple. So we have two presentations. The first one is about, so there's going to be an overview and introduction of the concept, and then we'll get a bit more practical with Themis, which will explain a bit more how to prepare and store service repository and make it preservable and accessible on the long term. Then, of course, we will have space for Q&A. Please use the Q&A function here on Zoom so that it will be easier for us to keep track of all the questions that come in. We will pick them up at the end, so we'll have about 15-20 minutes for discussion. Feel free to add your questions also during the presentation, so don't worry, you don't have to wait until the end if you wish to ask anything. What is FairCore for EOSC? FairCore for EOSC is one of the, let's say, it's one of the new wave of Horizon Europe EOSC-related projects, which are picking up the legacy of the Horizon 2020 projects that had contributed to building, let's say, the foundations of what EOSC is becoming. And in particular, let's say that this consortium is working on the gaps identified in the SRIA, and you will learn a bit more about this. And you can see here our team, which met at the kickoff meeting last June. So we're just completing our first year of activity. And then when we met in Kajaani, Finland, for the technical project meeting. So the project is coordinated by CSC, and it's 36 months. These are the 9 components that FairCore for EOSC is developing. I'm not going to go through all of them. Just know that the work package that's responsible, let's say, for today's webinar is work package 6, and this is the work package that works on the research software related components. So you will learn a bit more if you visit our website. Then you can also find our quarterly project briefings on the website. That's where we collect the most important updates coming both from the development side, but also from the case studies side. And you can find them on our Zenodo community. You can download them very easily via the website, and I will share the link in the chat in a second. Apart from today's webinar, we have also organized another one for tomorrow. So data cite, it's part of the open hour series, and that will work more as a consultation on the PID graph that the team is developing. You can find the link here in the slides, but of course, I will share this also in the chat in a minute. So we look forward to meeting you also tomorrow in this other webinar. But for now, let's enjoy this adventure through the software heritage with Morane. Please, Morane.
I think someone raised the hand. Sorry for that.
Andreas?
Not sure.
Hello? Andreas?
Maybe
no, maybe it was a mistake.
Sorry.
Okay. Please, Morane.
Thank you, Federico, for this welcoming introduction. I'm going to share my screen and start just after that. Let me see. Okay, trying to share just a second. Can you see my screen?
Yes.
Good. Thank you for letting me know. So welcome, everyone, and I'm so happy to be here on this webinar. My name is Morane Gruenpeter. I am a software engineer on the software heritage team at the INRIA Research Center, and here I am in the capacity of leading Work Package 6, where we have various partners, not just software heritage, and I will discuss today archiving source code in software heritage. And so before going into the depth of archiving software, what is software? Now, I want to clarify the magic. What's the difference between a software, what we think of a software, something that's doing and solving a problem, a project, and a community around it. So that's the software as a concept, and the software artifacts that we want to execute or read as software source code. Those two things are very different and should be considered when we identify software, when we describe software, and finally when we archive it. Now, software source code is special, and this part of this webinar today is to clarify why do we want to archive software source code, because software is not just another type of data. It evolves over time, but it's crucial for science, for research. Now, we do know that software is very complex. It can be millions of lines of code. It might be a large web of dependencies, as you can see in the mem here. It easily can break if something happens and difficult to maintain. And there's a sophisticated developer community. Now, there are software that are small and don't have such big sophisticated complexities, but we need to consider everything when we identify software and archive software. In this webinar, we specifically want to look at research software, which is software that's created during the research process and for a research purpose. We use this definition from the Fair for Research Software Output, where software in research is different from research software. Now, why it's important? It's important to see that software is a first-class output alongside publications and data. And that's why it's a key pillar in open science, next to open access repositories and open datasets repositories. Now you can ask yourself, what's the software all about? Now, software has multiple facets. It can be a tool used in the research process, but it also can be the research outcome or result. And finally, it can be an object of research when other teams do research this object. And to add a bit of complexity to it, it can be all three facets at the same time by different research teams. Now, the use cases that we see in this academic context are very diverse. We have the researchers that want to archive and reference the software to be more recognized and get credit for the developed software, and might want to verify, reproduce, and improve results. Also find useful software. Next, we have the laboratories and teams that want to track software contributions, produce reports, maintain web pages. And we have research organizations that want to know the software assets in different processes like strategy, impact metrics, and technology transfer. We do have the curators that need to verify and create software metadata, provide some documentation to better curate software and monitor research teams' production. And we need to make software a first-class output. And when we are here in this webinar, we do think that it's already a first-class output. We have still a long path to go. And with the Fair Call for EOSC project, this is one of the goals, is to make this change and make this possible in the scholarly ecosystem. Now, you see on this part, the NOSEC pyramid of making a culture change. And we are at the bottom level and one of the crucial levels, which is the infrastructure, by making it possible. And we have different partners and different infrastructure. But here it's not only the Fair Call for EOSC partners, but different infrastructure that can make this possible. If it's publishers or scholarly repositories and aggregators, and also Software Heritage, the Universal Source Code Archive. Now, what is at stake? We need to make sure we can access to to the software by archiving it. We need to make sure we can identify the software artifacts by referencing a specific version. We need to make sure it is rewarding to create software by giving credit to authors. And finally, this is for today, we need to make it easy to discover by describing software. Now, recently in 2020, the Scholarly Infrastructure Working Group produced the SEERS report. It's an EOSC report focused on software source code that produced recommendation and best practices for the scholarly ecosystem, identifying the relationship between different infrastructure, between aggregators, publishers, scholarly repositories, and the Universal Source Code Archive, which is not only catering the scholarly ecosystem, but other sectors as well. And in FAIRCore for EOSC, with Board Package 6, we are trying to implement, we're not trying, we are doing it. We are implementing the SEERS report recommendation with a few identified partners. Now, why archiving research software is so important? Because software source code is fragile. It can disappear, it can be deleted, infrastructure, a commercial infrastructure can be bought, and then many repositories can be lost. It's important to know that software source code that's publicly available online is very fragile, like anything that's on the internet. Now, Software Heritage has this incredible mission and was created as an international and non-profit infrastructure in 2016. And behind Software Heritage, there are many partners, sponsors, and other organizations that share the vision of archiving software source code. The mission is to collect, preserve, and share source code. And it's done with different mechanisms. There's the possibility between Software Heritage and infrastructure to deposit software by submitting the source archives and associated metadata. Software Heritage is actively crawling the existing forgers and package managers to have and hold all the software source code. And there are mechanisms to actively go and save code by saving a project or identifying a full forge. Finally, Software Heritage is also doing rescue operations with forges that already closed and are now safely in Software Heritage. Now, just to let you know that it's very easy to do a save code now, and you don't need to be the author of the software to do it. It's like the Wayback machine in the Internet Archive, where you can archive any URL online. So you can just add the URL of a Git repository or another type of version control system and submit it, and it will be saved. There are also two other options with the webhook endpoint and the browser extension. The browser extension is making it easy. By adding it to your browser, you will have this save icon that you can click whenever you are on a repository that you want to save. When it's yellow, gray, or even red, well, red you can save because it's private, but the gray and yellow one, you should be able to save quickly software when you are on a forge. Now, we talked a lot about archival, and here today we want to talk also about finding software and how we describe software and where is this metadata that's describing software. So we have two types of metadata. We have the extrinsic metadata that lives alongside the software on an infrastructure. So it can be on a registry or an aggregator. It can be on a scholarly repository with a metadata record. It can be on a publisher's platform, and it can be on, well, that's the scholarly options, and it can also be on the development platforms, on the platform page, or on the package manager platform. And this metadata is with the software, but not in the software. We want to show you that having the software in the code repository might be more useful for the software. By being in the code repository, it's archived with the code as embedded in the code. We have different types of metadata files. Some are human readable, like the README, describing what the repository or this software is all about. You have also the license that is human readable. And you have some files that are machine actionable, like the code meta.json file, which you can see on the slide, but there are also package management metadata files that are also machine actionable, that are used directly in the packaging process. Sharing a piece of and just a small example we have worked a lot on is the connection between HAL, which is the French National Archive, and software heritage, and is the example we are using to develop the other components in Wayback 6. In this example, you can see that a researcher is working on a version control system, submitting the repository URL with a safe code now that you have just seen. It's very easy to use, and getting this, what we call a SWID. Now, today, I don't have a lot of time to explain what is a SWID. A SWID, a software heritage identifier. I can just say it's in an intrinsic identifier that you can then use and submit on the HAL platform with metadata, which will be extrinsic metadata that will appear on the metadata record. Now, if the researcher here had a code meta.json file in the repository, HAL will know how to read this file. It will import the properties to the record, and then this software record will be moderated by software curators and moderators behind the scene and be accepted. And after this validation, this software will be published. And this is how it looks on the HAL interface, and then on the software heritage interface, where you can browse the source code. This is quite interesting because having this possibility makes you archive the full development history using software heritage, attaching a metadata record to it, so it's discoverable on the HAL infrastructure. And then you also have the intrinsic metadata, which is indexed in software heritage. That's also very nice. And with the HAL platform, you can have a software citation and browse the code in software heritage. Now, why am I telling you this? Why HAL? Well, this is one of the examples we already have implemented and in place, but with the Federico for EOSC project in Wayback 6, we intend to do it with different other infrastructures to provide tools and services for archival, reference, description, and citation of research software artifacts. And this is making the EOSC report a reality. There are the two EOSC-Core components that are delivered from the Wayback 6. One is this connector, which is called the research software APIs and connectors, which will ensure long-term preservation of the research software. And we have also the software heritage mirror here that will be deployed by GRNET. Finally, we do have one of the objectives about setting up a regular archival of the EOSC-Core components in software heritage. That will be shown by Themis just after me. We have an ambitious roadmap ahead for this project, but which is part of the larger software heritage roadmap to collect preserve and share all publicly available software source code. And now, just one last comment before we move to Themis is why code meta? Now, code meta is a vocabulary. It's a subset of schema.org. There's an academic community discussing software metadata and kind of the semantics behind the terms that are used in the code meta vocabulary. And the interesting part and valuable part that made us choose code meta as the vocabulary that we are translating to in software heritage, it's the crosswalk table. This crosswalk table is a mapping of the metadata landscape that you can see in this slide. So in this landscape, you have many software schemes, and this is not an exhaustive diagram of the metadata landscape. The landscape is much larger than just these vocabulary, but it's to give you an idea what is out there. And you have in these software specific schemes that are vocabularies that are specifically for software. And there are some general schemes that are that do have the possibility to describe software as well. As you can see in schema.org, there are two classes, the software source code and the software application class, which is the ones that are subsetted by code meta. In this part of the slide, we have the scholarly ecosystem. So a few vocabularies that are specific to the scholarly ecosystem. And there are some vocabularies from catalogs and registries and some from package managers. And so to organize a little bit this very diverse landscape, we found this metadata crosswalk table, providing really a translation between properties. And this translation makes it possible for us in software heritage to index different metadata files, not just the code meta.json file, and index these properties so that the software can be findable with this intrinsic metadata. Now, I hope that was not too much information. I want to thank you for your attention and keep in mind that archiving software is easy, so you should do it. Even if it's not your software, you can archive things that you think should be archived very quickly. And to make it available and indexed and findable, you should describe your code with metadata, with intrinsic metadata. So if there's something happens to the platform or to the metadata record, the source code itself holds also the metadata. A final note before I let you go is the hot from the press. We have just released a first draft, which is not yet approved by the European Commission, on the Fair Impact project, which is called the Guidelines for Recommended Metadata Standard for Research Software within EOSC. And inside this deliverable, you will find what we call the Research Software Metadata Guidelines and a checklist that gives you kind of a hands-on approach on best practices for research software and metadata. That's it for me. Thank you.
Thank you very much, Morane. So I think we can move on to Themis' presentation. So, and I've seen that there's already a question, but we'll keep it for the end. And in the meantime, you can think about it if you want. So Themis, the floor is yours.
Can you see my presentation?
Yes, but we cannot see you.
Slide mode. Oh, sorry. I opened only my voice.
Yeah, so, it's working.
Thank you. Okay, let's start with the second part of this webinar. Okay, we have seen a lot of things that Morane will explain to us about how software heritage is working, the different calls we can use, the code meta, the metadata, and now let's see an example of how we started and how we used all these details in our task. First of all, I would like to introduce myself. I'm Themis Zamani. I'm from GRNET. I'm working as a senior project manager, and I'm also the head of the implementation unit of the European Infrastructures and Project Directorate. In the FAIR-Core for EOSC, we participate in a number of core components that were introduced in the first session, like the PID meta resolver, the PID compliance assessment toolkit. And one of our main tasks was also the creation of the component for the archival of the EOSC-Core components to the software heritage. And this is what we're going to discuss today. So let's start. When we first started the project, we knew only that we had to set up a regular archiver in software heritage for the EOSC-Core code hosting platforms. That was something that we had to understand and, let's say, being as a part of the software heritage so that we can understand what we're going to do. The first part was to refer to the EOSC-Core components. When referring to EOSC-Core components, we're referring to a set of services that provide the means to discover, share, access, reuse data and services. These are services that are offered via the EOSC Future project right now and have to do with some of the services maybe you are already using in EOSC, like the authentication authorization, the marketplace, the help desk, the recommender service, the accounting, the monitoring. So the easy part of our task was to collect the different repositories and, of these EOSC-Core services and their components. From the other part of the task was to follow the software heritage development process. One of the main features of the software heritage is that it has a set of services, well-defined documentation, and open web APIs that help you interact to archive your code repositories. Our mission was to start using them to understand how they are working and how we can interact with them so that we can finalize our script. We started collecting the repositories. We made some tests with the software heritage APIs, and we managed to create our archival script. The first version of the archival script was ready, and our first goal was achieved. The what of the archival script? The script reads a list of the repository sources along with their type, because some of the repositories were in GitHub, some are in SVN, in subversion SVN. And what it tries, it attempts to archive each single one of them through the software heritage API. The prerequisites we had was the list, and to understand the common functions of the software heritage APIs. So the process was to get the list, use the visit API call to determine the repositories is already archived, the save API to get details, and to produce the report. In this slide, you can see in details what the repository archiving script is doing, and that it provides functionalities to read the different details of read as file input the list of version controller of the repositories. Then we use the visit API call to return information about the archival of the repository, if it is archived or not. And then we get information about their status, and we started archiving them. The last and final step of the script is to create a report so that we can know the status of each repository. The report is just a single file with each line where each line represents the archival data of one of the provided repositories. We have an ID, we have the URL of the repo to be archived, the type of the version control, the status of the request, if it is accepted or not, the status of the archival, if it is scheduled or not, and the timestamp of the archival request. So every time we run the script, we know exactly the status of the archival of each repository. So it was a success. we have our first report. We almost archived all the different repositories, and we renew the list of the repositories every time a new repository is here. But although we have archived these repositories, we just archived the URL, and we had some questions to answer. First question. The first question was, how can we search for these new repositories that were archived in software heritage? And the second question was, okay, I can search with the URL, but how can we add more information for these repositories so that can everyone easily find the code it's looking for based on some metadata, based on a name, on a description, and metadata like we all use. For the first question, which was how can we search for the new repositories, the answer from the software heritage is that we have a solution for this, and we have a web page where you can search for the repositories either by the URL or via some metadata. The basic search is through the URL, but you can search also for some metadata, but it's a work in progress that will be finalized in the next few months. And some of the indexing will not work. So you can search with URLs and with metadata. Okay, I can search with metadata, but how can I add more information for these repositories so that everyone can search with this metadata? And the answer to this question was what Morane also described earlier, to use the code meta. The solution for that is the code meta. The code meta is the goal of code meta. It's to create a concept vocabulary that can be used to standardize the exchange of metadata across repositories and organizations. And so a code meta instance file describes the metadata which are associated with each repository we want. How they're associating, they are using JSON linked data notation. So software heritage, as already Morane explained, already decided earlier to use the code meta vocabulary internally where indexing the metadata. So the solution to our problem is to create code meta JSON files for each repository. But okay, I can create a repository. I know that we can use metadata, but the question we had from some repository owners were, is the script responsible for everything? What should I do from my point of view? Should I do something? The answer to the repository owner is that he's responsible to create the metadata JSON file for the repository. And the service owners are the ones that know the exact information, that the metadata information needed for the repository. And what the answer from us is that it takes you up to 10 minutes work to make your repository famous to software heritage. So actually, by the time a repository owner adds this metadata JSON file to the repository, everyone can search through this repository, through software heritage for his repository with the metadata. Is it easy to make this metadata file? There is a code meta generator file, which is an easy to use tool to create your code meta JSON. In the next few slides, we are going to see the different components that you have to fill in, the different information that you can fill in via the code meta generation, so that we can easily create the code meta file. So the first part and the most useful part is the identity, let's say, of the software itself. The name, the description, when the project was created, and the first release date. These are, and of course, we don't have to forget that we also need the license, because it is important to note that using the licenses, the license identifier makes the information more interoperable. So we have to add this information to start describing our software in the software heritage, in the code meta JSON file. Apart from the form, you can also use, there is also some API endpoints that can be used from GitHub and Subversion that can easily help you find the information you have already defined in the repositories, so that can be used for either for the code meta or for machine readable APIs that you, actions that you want to use. So, as Morane already mentioned in the previous presentation, there is also a crosswalk for GitHub API, which is the mapping of the metadata, the properties. This is the translation of the properties in the software heritage and the GitHub properties and the properties using GitHub. So if when you want to use the code repository for software heritage, it's the HTML URL from the GitHub API. That is useful when you want to find information to fill in your metadata code file. The second part, which is also useful, is the authors and the contributors. Usually when we have a repository, the only way to add your contributors is by adding them as developers in your repository. But here, you can add more information about the authors and the contributors by adding the given name, the family name, the ORCID URI, an email, and the affiliation. So you can add more metadata for your authors and contributors via the code metadata file. The other part is the discoverability and citations, where you can add information about the unique identifier your repository has, the application, category, keywords, funding, and the funder. So it's information that the service owner should add, and that it advertise more, helps more the discoverability and citation of your repository. The other part of the metadata are the development community tools, which is actually where you host your repository, where is your continuous integration platform, where someone can create issues, and of course other related links that have to do with your project and your repository. The other is the runtime environment, the type of programming language, runtime platforms, operating system, and software requirements you use in your project, in your repository. And finally, it's the current version of repository. We can add, you can archive you can archive the current version of the software, which is the release ID, the release date, and of course, where can someone download it and add the changelog of the current version of the software. Finally, it's this information, it's the code data, metadata, the additional information about the repository, where here you can add information about how to connect components, sub-components, or even projects between them. So actually, the is part of can be used to connect a sub-component with a specific service or with other components. Another part is the development. Another information that is used here is the development status, which is in our case, we for example, in the example we're going to see in the next few slides, we used the active one, which is a project that is stable, usable, and is being actively developed. The other information about the status could be work in progress, that is in initially development, and inactive, that it's not used anymore. So when you add all this information, you can here we have the EOSC messaging example, which is a EOSC-Core component. And here we added all the information that we want for the EOSC messaging, the name, the description, when it first created, the current version of the software with where you can find information about it, the authors, the contributors, the development, the tools that we use, and of course our latest release. And by using this code meta generated, we created a JSON file with all this information in it. And the main information that is connecting this component with the EOSC-Core is part of the EOSC portal. This is the main URL of the project that we're referring to. And we added the funders, the keywords of what is doing, programming languages, the authors, and the contributors. These are the main information that we added so that everyone can start searching for this type of our main EOSC-Core component. If I was asked, what are the list data that we should add in our code meta file? The first answer will be that all information is necessary, and each different type of information helps something different. But if you want to have the first version of your the metadata JSON file, the list information that I would put would be the first part, where you describe the software with a name and description and where this is when it was created. Of course, the authors and the contributors. Some information about the discoverability and the citation, and finally some information about the additional info so that to connect the service to the bigger to the project. These are the list information needed, and this is what we propose to all the service owners of the EOSC-Core components to add as information, so as to make their software repositories searchable in software heritage. That's all from me. If you have any questions.
Okay, thank you very much, Themis. Okay, so let's do like this now. So, okay, we can unshare the screen. Okay, so Morane, you're also online. Okay, perfect. Okay, so actually we already had some questions in the chat. I see that Morane has been very diligent in replying to them while we were speaking, but okay, let's just go through them and comment while we wait if there's any others. Well, of course, the easy one is that the link, you can find it in the chat now. So the link that Morane just shared. Then let's go to the one that Sophie was asking. So as she mentioned, it's a bit outside probably of our mandate, but does software heritage consider adding a metadata field indicator on the efficiency of the software? So she makes the example of Code Carbon. So I think this is for Morane.
Yes, thank you, Sophie, for this question. Of course, this is a very relevant question in the today's world. As I explained before, we don't have a software heritage vocabulary, so we can't add a field. But this is something to suggest for the standard, the code meta standard, or any other vocabulary as a property that can be added to this vocabulary, so that it can be used. Then the question is how to use it. But yes, this is something that is not in the scope of software heritage, because we don't have this vocabulary. It's in the code meta scope.
Thank you. Then there was the question from John. So are there any prerequisites for archiving, such as ensuring an OSI approved license is present? So there's a very long reply here in writing, but I don't know if you want to comment on it. I think you froze, Morane. Okay, maybe let's move to the other one that I think was for Themis. So you mentioned codemeta.json. I guess you also harvest from potentially existing citation.cff files.
Morane has already answered this, unless they are reading also the citations of the files too.
Okay.
As a URL in 6p, the implementation status, I think. Let's open it.
Okay.
Yes, they support different types. That the URL explains the different types of metadata files that are supported. The citation, the code meta, the composer from PHP, all these different metadata files.
Thank you, and welcome back, Morane. So that
Okay,
was
sorry, I don't know what happened. It just stopped for a second. And then,
okay. Yeah. So going back to the question about the prerequisites for
yes,
archiving.
yes,
So if you
sorry
want to
about.
expand a bit on that.
Sure, thank you. So no prerequisite, because just the URL will suffice to just archive the repository. We do have recommendations that you can find on the Software Heritage website, and I put the link in the answer. So it is best to have a license, of course, an open source license, and some metadata in the software. A README is also very good to have, but there's no filtering on Software Heritage side. So we do not block software that doesn't have licenses or other types of information in the repository.
Okay, thank you very much. Let's see if there's anything else. So, okay, I think we have covered the ones that had come already. Okay. All right, well, so I do have a very easy one. So what would be the next, I would say, like, where can these experts meet you next? Do you have any other events in plan? Yeah, that's the symposium, for example, the Open Science Fair. Are there any events that you plan on attending that people can come and meet you in person, for example, to know more about these?
This is a very good question. The next planned event well, it depends if the submission is accepted. We have the RDA plenary, which is at the end of October, where we are planning as part of the software source code interest group at RDA to present the fair impact guidelines, and we will also share some information about the development of fair code for EOSC components. You should know that the components are only at the beta release level and will be implemented and released before the end of November, but it's a beta release, so might be not accessible for the large public. So stay tuned with our newsletter, the Fair Code for EOSC newsletter, to see when this is coming up and available for the large public.
Okay, thank you. Okay, so if there's no other questions, I would just like to invite everybody again to the webinar we're having tomorrow. So with DataCite, let me paste the link in the chat. So basically this one will work more as a consultation. So basically they will actually ask questions to the audience to gather feedback on the work they're doing on the PID graph. So you will find the registration link in the page, and we hope to see you there again tomorrow. Morane, do you have a raised hand?
Yeah, I have a question. I have a question for the public that are people that are here now before you leave. What kind of events or information would you like us to prepare? So this is something that I really want feedback on, because then we can do webinars about code meta, about archival or indexing or any other type of event. So you can tell us what do you want, what do you need?
Yeah, feel free to use the chat or even raise your hand. I mean, if anyone wants to comment on anything specifically, because I mean, I see that there are some names that we know, like from other projects and from other communities.
Or they can ping us and inform us if they want more information about something.
Yeah, exactly. Or yeah, you can just write to us as well if you can't think of anything now. But
for example, we can also put this in if we have again this type of webinar or a presentation about archival of EOSC-Core components, we can add the different types of files they can use for their metadata and explain to them. And because I think they are already using a specific type also, so we can add this information in our next presentation if we ever have another one about the archival.
okay. Well, all right. So just final announcement. Just note that you will find the recording of this webinar available on the Faircore for EOSC YouTube channel and on the website in the next few days. So as soon as the processing is completed, the slides will also be made available in the next few days. So of course, as soon as that's done, we will announce that on our social media channels and on our channel. So please follow us on Twitter, LinkedIn, YouTube, whichever is easier for you. And you will find more news from our side. So I don't know if you have any other final comments before we say goodbye to our audience.
Just thank you, Federico, for organizing this webinar and for the Wayback at 7 that is doing all the outreach work for the Faircore for EOSC project. And thank you for the audience that came and joined me and Themis in this webinar. And I'm really happy to see that they are interested in this subject, and we will try to make sure that we keep engaged with the community to give you the elements to archive better your software.
Okay, thank you very much. So we'll see you soon, and follow our channels to learn more about the components. See you.
Bye. Thank you.
Bye.